Okay, let's unpack this. Today we're doing a deep dive, requested by a listener actually, into Antimonium tartaricum, or AT.
Right, AT. And it really sits at this, fascinating crossroads between, well, a very long traditional practice and some pretty intense scientific scrutiny.
Exactly. The substance itself is derived from antimony potassium tartrate. Historically, it was known as tartar emetic, just a white powder.
And a pretty toxic one, historically speaking, which makes its use in this context a real paradox, because our sources show these two completely different stories, don't they?
They really do. On one side, you've got these detailed traditional uses, often for quite serious things, ammonia, bad bronchiolitis, stuff like that.
But then on the other side, there's the way it's prepared, which, well, from a chemical standpoint, it seems to remove any trace of the original stuff.
That's the core tension we want to explore for you today. We have sources on the traditional uses, the specific clinical picture they look for. Then there's the preparation method, the extreme dilution.
And finally, the really significant scientific pushback against the whole system. So our goal is to lay out the traditional claims, explain the process, and really highlight that fundamental disconnect with mainstream science.
Right, so let's start with the traditional side. What is Antimonium tartaricum supposed to treat, according to the sources like the Materia Medica?
Okay, so the traditional profile, the indications, they overwhelmingly point towards the respiratory system, especially in kids and older adults, the more vulnerable groups.
And this is based on that core principle of cures
Right.
the similia principle.
Exactly. The idea is a substance causing specific symptoms in a healthy person can, in a highly diluted form, treat those same symptoms in someone who's sick.
So if the original tartar emetic causes, say, breathing problems.
Then the diluted AT is used for similar breathing problems. But it's not just any breathing problem. There's a very specific guiding symptom they look for.
Okay, what is that? What really flags AT for a traditional practitioner?
The absolute key symptom, the one that really points to AT, is this great rattling of mucus in the chest. You can almost hear it.
Like the lungs are full?
Exactly, like the bronchial tubes are just overloaded.
Yeah.
And this is critical, there's very little actual expectoration. They can't cough it up effectively.
Wow, so they sound like they're drowning, but nothing's coming out. That's quite a picture.
It is. It's just a severe congestion, but also a failure of the body's clearing mechanism. And it usually comes with intense dyspnea, that's difficulty breathing.
And what about the person's general state? The sources mentioned it wasn't just the lungs.
Oh, absolutely not. It's a picture of profound debility. The person is typically drowsy, very pale, weak, sometimes described as feeling like the lungs are about to become paralyzed.
Yikes.
Yeah, and often there's a cold sweat, maybe trembling of the whole body. And one very specific sign is this incessant quivering of the chin and lower jaw.
That is incredibly specific. Quivering chin.
It is. That combination, the respiratory distress, the rattling with no output, the extreme weakness, the pallor, the trembling, that whole picture defines the need for AT in the traditional view.
And there are even finer details, right? Things that make the symptoms better or worse. Modalities, I think they're called.
Precisely. Modalities are key. For AT, the complaints are typically worse from heat, and especially worse when lying down at night.
Which makes sense with breathing difficulties.
Right, and they feel better from sitting upright. That posture often gives relief. Also, strangely, better after finally managing to expectorate something, if they can.
And it's not just lungs, is it? I remember seeing notes about stomach issues.
That's true. It extends beyond the respiratory system. Specific gastric problems like nausea and vomiting, but with a very peculiar modality. The person feels better lying on their right side.
Huh. Weirdly specific again.
It is. And also certain skin issues like pustular eruptions, even some types of chickenpox, especially if they leave behind bluish-red marks after healing. It shows how the remedy choice is tied to this whole unique symptom pattern.
And this isn't just dusty old books, is it? People are still researching and documenting this within that field.
Correct. We found a recent study published just in 2024, actually, in the International Journal for Multidisciplinary Research.
Okay.
And it was a retrospective study looking specifically at Antimonium tartaricum 200. That's another common dilution level for respiratory complaints in children. Things like common colds, laryngitis, and yes, bronchiolitis.
So the traditional practice continues, and they're trying to build their own evidence base for these very specific uses.
That's the picture, yes. An ongoing effort to document their clinical experience.
All right, so that's the what it's for. Highly specific, severe symptoms, documented tradition. Now, the how it's made, this is where things get Complicated.
Understatement. This is the core of the controversy. The process is called potentization.
Potentization, okay.
It involves two main steps, repeated over and over. Serial dilution, mixing the substance with a diluent, usually water or alcohol, and then succussion, which is basically vigorous shaking or striking the container.
And the claim is this makes it stronger, while removing the toxicity.
That's the claim from proponents, yes, that this process unlocks or enhances some kind of energetic medicinal quality while the chemical toxicity disappears.
Okay. Here's where it gets really interesting, and frankly, where it breaks with conventional science. The dilution levels. Let's talk about 30C. That's a common one for AT, right?
Very common, found in many over-the-counter pellets.
Can you walk us through what 30C actually means, like mathematically? For you listening, this number is key.
Okay, C stands for centesimal. It means a 1 to 100 dilution. So 1 part original substance to 99 parts diluent.
Right.
And the 30 means that 1 to 100 dilution step has been repeated 30 times in sequence with succussion at each step.
30 times. So that's 1 followed by 60 zeros, a dilution factor of $10.
Precisely. It's a number that's almost impossible to visualize. To give you some scale, diluting just 1 molecule of the original substance to 30C would require a volume of diluent vastly larger than our entire solar system.
That just sounds, yeah, impossible. And this is where basic chemistry steps in, isn't it, with Avogadro's number?
Exactly. Avogadro's number is fundamental. It tells us how many particles, atoms, or molecules are in a standard amount, a mole, of any substance.
Okay.
When you apply that to dilutions, the math is pretty clear. Around the 12C dilution mark, that's 1 part in 1024, you cross what's called the Avogadro limit.
Meaning
Beyond that point, it's statistically extremely unlikely that even a single molecule of the original substance remains in the final preparation.
So 12C is kind of the theoretical limit for having any original stuff left, and the common AT preparation is 30C.
Correct. We're talking 17 orders of magnitude more dilute than that theoretical point of nothingness.
So chemically speaking,
There's nothing there.
Chemically speaking, it's inert. The sources, like the Daily Med drug label for AT30C pellets, confirm this. They state the pellets contain less than 10-12 milligrams of antimony per pellet.
Which is effectively zero. It's chemically indistinguishable from the carrier substance, which is usually just lactose or sucrose. Sugar pills, essentially.
Okay, so if there's no active ingredient, 0 molecules of the original stuff, how do proponents explain that it works? What's the proposed mechanism?
This is where we get into more, let's say, unconventional ideas. The main hypothesis put forward is water memory.
Water memory.
The idea is that the water or alcohol used in the dilution process somehow retains a memory or an energetic imprint or a vibrational pattern of the original substance, even after the substance itself is gone.
And it's this memory, not the chemical, that supposedly has the therapeutic effect.
That's the proposed mechanism, yes. It's argued that the succussion process is crucial for imprinting this memory onto the diluent structure.
What does mainstream science say about water memory?
Mainstream science says it contradicts fundamental principles of physics and chemistry. Water molecules are constantly moving, forming, and breaking bonds on incredibly short timescales.
What's fascinating here is if water could hold stable memories like that.
Well, think about it. Every glass of water you drink would contain the memory of everything it had ever come into contact with, every mineral, every pollutant, everything. It would be chaotic information soup.
Right, not a stable therapeutic signature.
Exactly. So the scientific community generally views the extreme dilutions and the water memory concept as scientifically implausible. This is really the central point of contention.
Which brings us squarely into the third part of our deep dive.
Yeah.
The scientific consensus and the regulatory view. When you look at large-scale studies, clinical trials, what's the overall picture?
The overwhelming scientific consensus is pretty stark. Homeopathy is often characterized as pseudoscience. Rigorous clinical trials and meta-analyses consistently find that homeopathic remedies perform no better than placebo.
No effect beyond placebo. That's a strong statement.
Yes, but it's important to add a little historical context here, which the sources touch on. It's easy to dismiss it now, but back in the 19th century when homeopathy surged in popularity, conventional medicine was often brutal and dangerous. We're talking bloodletting, purging, giving people large doses of toxic substances like mercury or arsenic. Treatments were often worse than the disease.
Right. So compared to that,
giving someone an inert sugar pellet, which at least did no direct harm, could seem like a much gentler, even more effective approach simply by letting the body heal itself without interference. It was comparatively safer then.
So it gained traction. partly because the alternative was actively harmful. That makes sense in that historical light.
Precisely. But today, obviously, the situation is reversed. We have evidence-based medicine that is demonstrably effective and rigorously tested for safety for many conditions.
While homeopathy remains chemically inert, that context shift is crucial. So how do modern regulators handle these products like AT that are still sold? Take the U.S., for example.
In the U.S., it's complex. As we saw from the Daily Med source, Antimonium Tartaricum is available over the counter, but it's labeled as an unapproved homeopathic drug.
Unapproved, meaning?
Meaning, the FDA hasn't evaluated it for safety or effectiveness like it does conventional drugs. And the label explicitly states, this is a direct quote requirement, that the FDA is not aware of scientific evidence to support homeopathy as effective, and that any claims made are not FDA evaluated.
So it's sold, but with a very clear warning that there's no official scientific backing for its claims.
Exactly. It exists in a sort of regulatory carve-out based on historical use,
Yeah.
but the scientific disclaimer is prominent. And this skepticism isn't just the FDA, it's global.
What do other major health bodies say?
Major international health organizations have reached similar conclusions. The UK's National Health Service, the NHS, has largely stopped funding homeopathic treatments, citing lack of evidence.
Okay.
And major scientific review bodies are even more direct. The Australian National Health and Medical Research Council did a huge review and concluded there's no reliable evidence that homeopathy is effective for treating health conditions, period.
Wow, no reliable evidence.
Similarly, the European Academy's Science Advisory Council looked at the evidence and also found efficacy doesn't go beyond a placebo. The scientific consensus is remarkably consistent worldwide, pointing to those dilutions.
Now, the sources also mention risks. If the pills themselves are inert sugar, where's the risk? It's not usually direct harm from the pill itself, right?
Generally, no, assuming it's properly prepared at high dilution, although errors can happen. But the real danger, the one public health officials are most concerned about, is indirect harm.
Indirect harm, meaning?
Meaning someone uses a homeopathic remedy instead of seeking or continuing with conventional, evidence-based medical treatment for a serious condition.
So relying on AT for severe pneumonia in a child, for example, instead of antibiotics and hospital care.
Exactly that. Or for other serious infections or chronic diseases where effective treatments exist. Delaying or foregoing proven therapies while relying on something inert. That delay can allow a disease to progress, sometimes with tragic, even fatal consequences. That's the critical risk.
So what does this all mean? We've traced this substance, AT, from its traditional use for very specific, severe symptoms.
Based on like cures like?
Through a preparation process involving dilutions so extreme they defy chemistry as we know it.
Leaving essentially just sugar.
All set against a backdrop of near-universal scientific consensus that says it doesn't work beyond placebo, and regulators warning consumers about the lack of evidence.
It means we've laid out the two distinct realities presented in the sources. There's this rich, detailed history of traditional practice, with its own internal logic and dedicated practitioners, and then there's the objective analysis from chemistry, physics, and large-scale clinical trials, which finds no verifiable effect from the final product.
It's a stark contrast.
It is, and the value here, for you listening, isn't about picking a side in that moment. It's about understanding the different kinds of information presented, the traditional claims, the scientific data, the historical context. It's about knowing what each source is telling us.
A really crucial exercise in evaluating information.
Absolutely. And if we kick this back to the bigger picture, we mentioned homeopathy gained ground when conventional medicine was harmful. Today, we have effective medicine, but we're flooded with conflicting information. This raises an important question, doesn't it? How should we, as critical thinkers, apply the scientific method not just to evaluate the remedy itself, but to evaluate the sources and the contexts, historical, traditional, scientific medicine, that promote or debunk it? It's really the challenge of sifting evidence from belief, data from dogma, wherever we find it.
That's a powerful thought to end on, applying that critical lens not just to the what, but the why and how of the information itself.
Precisely. That skill is maybe the most important takeaway.
Indeed. Well, thank you for navigating us through this complex and definitely controversial topic. That's all the time we have for this deep dive. We hope you feel well informed.